Hey guys, Mr. Fortin here. Happy Monday. It is dark outside. It is nighttime. I'm doing this because you're doing this for homework. You're probably doing it at night. Hopefully not too late at night. Again, your math homework, algebra homework this year as a ninth grader, no more than 30 minutes on any given night. So if it's a problem set, no more than 5 minutes of problem. Don't do more than a half hour. This one here hopefully should only take you about 10 minutes or so, or maybe 20 minutes if you give it a shot for 10 minutes and then you watch this video and have to fill in the answers afterwards. I don't know, 20, 25 minutes. But anyways, you're watching this video because I'm going to do it with you. Normally, this is a question we do in class. For homework, you're completing problems 173 on page 33 in the Desmos task. Okay, so that's right here. I got the picture. You don't need to actually open up your textbook or anything like that, but you're just going to answer this question. You're going to do it in the Desmos so I can see what you write and then give you feedback on it tomorrow. Okay, so note that this problem is usually completed with your groups, so I decided to film this video. Hi, and you can check your answers. So try to do the problem on your own first. So try to do this Desmos first, and then watch this video afterwards. Make sure you got it right. Make sure your understanding is kind of roughly around where my understanding is, and we can start our next class in a pretty good place here. Okie dokie, so let's go ahead and into it. I'm going to go to slide 2 here. It says, write your answers by drawing and showing your thinking. So question 173, part A here, we're going to be examining the graph of function g of x at right. So we already dealt with function f of x. Now we got function g of x, right? Again, these are just ways that we classify functions, right? We do function f here in this part of a problem. Now we got function g in this part of a problem. It's doing something different. What is it doing? Ooh, it's all wavy here. It's all wavy here. This is kind of an equation we haven't seen yet before. Ooh, haven't seen it before. And there's also something going on here where we see kind of like endpoints. Ooh, that's interesting. All right, so here I'm going to kind of actually give you like a vocabulary word for these ones. This is called an endpoint, and it means that the function doesn't continue on beyond that. So that's a little bit of a hint here. Okay, also another thing that we're doing right now, the reason why you're doing this assignment, I want to have you doing this here, just to back it up for a second, is that you are going to learn about some things called domain, there we go, domain and range. Okay, this is your domain and range assignment. We're going to finish this one up on Wednesday, but you got started and you learned what domain was today. And what domain is all of the x values that can get accepted into a function, So the one you did today, I believe it was -3 couldn't go into the function because that would cause a denominator of 0. And you can't divide by 0, right? Not allowed. So the value of -3 would be excluded from the domain. So the domain of that one you did today was all values aside from -3, or it might have been +3. I forget if it was x plus 3 or x minus 3 denominator. Anyways, we talked about domain. What we're going to talk about today is something called range. Domain and range. And the thing about domain and range is that it's a way to describe the restrictions, okay? The restrictions of a particular function. In terms of the restricted inputs, we are restricted to only certain inputs of a function. And we could think about maybe what this function's inputs are restricted to right here. And we can also think about what its y values are restricted to, what its y values, what outputs come out here, okay? So the restrictions here have specific name forms. What our x's are being restricted to is called the domain. So that's what x's are being restricted to, is the domain of a function, x right here. And then the range of a function is what our y values, or our g of x values in this problem, are being restricted to. I think this is a y right here. Maybe like a backwards y. Not really a y, but anyways, that's that. So maybe you put that in your notes. Domain is your x restrictions, and your range is your y restrictions. And we're going to learn how to describe them in this particular assignment here. Anyways, I put my endpoints down there. I just wanted to point that out, that means that if I see points here, the graph doesn't continue forever. If I see arrows at the ends, okay, that means this continues on forever this way, right? Even if I just see an arrow right there. So say if this is over like -3 and goes up to like +5 or so, and I have arrows, it goes on into positive infinity, right? It would go on a positive infinity, not just +5. Anyways, that's not part of the problem here. It's just something worth pointing out because not everybody notices that out the first time through. Okie dokie, let's just do 173 anyways. Is g of x a function, and how can you tell? And I'm going to say yes, and I'm going to justify it through this. This is definitely a function. Yes, because each input input has exactly one output. Or at most one output is probably a better way of putting it. Okay. Yes, because each input has exactly one output, or at most one output. And we can see that through something. The way you test this is the vertical line test. So here, check it out. If I got an x of 2, how many y values do I have on the graph when x is 2? Oh, I got 1. I got 1. It doesn't really matter what the y value is, but it's like around 1 or so. And like it's just one output. One x value of an input could be x equals 1. What output do I have? Oh, a little over 2. What about an input of 1.5? Oh, I have an input of around 1.75. But the question is, how many outputs do we have for that input of 1.5? We only have one output. We have one output here, right? When x is 3, we have that one output right there. When x equals 2, we have this one output right here. When x equals -1, we have this one output right here. What am I drawing in too? What am I drawing in here to give evidence to the fact that I have only one output for every input? For every input. What am I drawing? I'm drawing vertical lines. Okay, so this is where my TAs made a video and I sent it out to you guys. But it's something called a vertical line test. It's a way to double check if something is a function or not. And you can just draw a series of vertical lines. And if you only graph the function once, that's going to tell you that when x is 4, for instance, there's only one y value, corresponding y value. We have a point at 4, comma, -1, it looks like. And we don't have any other points that have an x value of 4, right? In a different y value, for instance, here. So this is a function. Yes, because each input has exactly one output, or each input has at most one output, because over here, we're not actually, it looks like we're not allowed to put inputs in. We're not allowed to put inputs in at 6. Okay, and that's going to get us to the next slide. It's going to get us to what domain is. Let's go to the next slide here. Which x values have points in the graph? That is, what is the domain of x? Okay, so let me check this one out right here. And we're actually doing domain here. All right, talking domain of g of x here, okay? So what you should have learned today in class on question 172 is that domain equals what x values are represented. Oh, so messy. Represented or allowed. That kind of looks like allowed in the function. Here, I have to go to my in the function. Is that even English right there? I don't know what to tell you. Domain equals what x values are represented or allowed in the function. You have to write that down, and hopefully you can read it too, but probably not. So anyways, check this one out here. So to get our domain, what we do, the way that I recommend doing this for domain is figuring out, remember the x-axis is this one. This is our x-axis, right? This is all the x values that exist that are real x values, real number x values. This is called the real number line, right? Real number line from left to right. You should have studied that in middle school, the real number line. And x values could potentially go from -infinity, right? Over here, -infinity, all the way up to +infinity, right? The coordinate plane, the axes, go as we go to the right, we get more positive, we get bigger for x. As we go up, the y gets bigger, but we're not worried about that. We're talking about x for this one here, okay? So the x-axis is showing us the existence of all potential inputs. But the question is, what are the inputs of this particular function? And I'm going to change color so we can see it a little bit more clearly. Here is how I'd recommend doing this here. Start furthest to the left, okay? Furthest to left, which would be like right here. There's a point right there, okay, furthest to left. And here, this would be my minimum x value, my lowest x value. So the domain of x here, I would say, is this, -2. And it goes, look, the graph goes like this, right? It goes this way. It goes like this. I'd maybe trace over it. You can trace over here. The question is, when do the x values end? Remember, the x-axis is our left-right axis, right? Left-right axis, left-right axis. So it starts at -2 and it goes all the way to 4. Goes all the way to 4. So -2 to 4 is the domain. It's really hard to write clearly on this. So I might have trouble grading this for you guys a little bit later here. Okay, -2 to 4 is the domain. Another way I can tell you're talking about domain is to write an inequality. So if the question is, right, remember domain, what types of values are domains? Are those X or Y values, right? The domain is the X values that are part of this relationship. And for this particular relationship, our domain starts at -2 and goes all the way up to +4, all the way -2 to +4. Those are the X values here. So another way to write domain is using inequality using the X variable. So -2 is the smallest X value. So I could put an equal sign here, could equal X, but for the most part, it's gonna be less than. -2 is less than all the values of X we see in between here from -2 all the way up to +4. -2 is less than or equal to X, but let X doesn't, this X value of our particular graph, remember, this is where our graph is this little curve right here. And our graph ends when X equals 4. That is something called a continuous graph from the domain -2 to +4, kind of a little piece of a larger function. But this function, we just care about that particular piece for it. So -2 is less than or equal to X is less than or equal to 4, and that is another way to describe the domain. Yeah. All right, cool. Let's keep going here, guys. There's lots to explain on this. It's going to be a longer video than expected here. All right, what are the possible outputs for g of x? This is called the range of the function. All right, talking range here, might as well go to red for range. And the possible outputs for g of x, okay? All possible outputs here. So what we have for range, and you should put this in your notes, range are all the outputs, and so then we got to think about all the y values. All y values that are not just possible, but are represented. All values represented. Right, or given, right? Given because they're outputs, right? They're given from the inputs or given by the function. So an equation can tell us a bit about what our outputs will look like, but a graph certainly shows us what our outputs look like here. Okay, so remember, if we're thinking about outputs, we got to look to our y values. Okay, and again, that's why I wrote y values right there. So what we got to check out here is we got to check out our y-axis. Check it out. Our y-axis is right here for our dependent variables, right? This is our second axis. Remember, number lines, in middle school, number lines usually just go left, right? But if we're comparing two number pairs together, right? Number pairs together, we have an x coordinate and a y coordinate that are paired together. Input, output. And here, the y axis, the vertical axis, is the output axis here. This is what's going to tell us what our range of our particular function is here. Okay, so you have domain for the x values that are part of the function that are shown on the graph, and then you have the that's domain for the x values, and then you have range for the y values here. Okay, so remember, same thing with the y-axis. For the x-axis, that we have one direction that's positive, getting bigger and bigger and bigger. That's up here. And remember, the axes get smaller and smaller and smaller, more and more negative down here. So the goal of this problem, kind of the tricky thing of this problem, is actually reading your particular graph. Remember, this is our particular graph right here. That's our particular graph. So what I need to do, the way I recommend usually doing this to get the range is right here. Okay, finding the lowest point, the minimum point down here. And our minimum point here is -4. Oh, not -4. Ooh, that's tricky. Yeah, it's not that. It's not -4. What is it? Let's go back to it here. It's -1. Okay, it's -1 right here. All right, right? Because this is it. This is right here on our axes here. It's -1. Okay, and here is where I'd start here, right? Start here, draw a little horizontal line, start here at -1, and I got to go up. I got to go up to when? Tell me when to stop. Tell me when to stop. When am I stopping? When am I done with my range? When are my y values at? Well, it looks like my y values end right here, okay, right here. So with this is our range of this particular relationship, of this function. And here, the lowest y value that exists is -1, and the highest, right? If we traced this graph, right, we'd be at at the ends of the graph here, we'd be at a -1. But earlier in the graph, right? Remember, we usually read from left to right. Here I'm going right to left. Earlier in the graph, right? This is where we topped out. And then here, we already had points that were over here, okay? This is still a function, remind you. But here, look, our y values are repeating. They're repeating, but for two different x values, two different x. That's fine. As long as one x gives one y, right? 1x gives 1y, this passes the vertical line test, right? 1x gives 1y, it's still a function, okay? So, but here our range is from -1 all the way up to 3, okay? So -1 to 3 is the range. Okay? A better way perhaps of writing that out, okay? A better way perhaps of writing that out is to use inequalities, what I told you about earlier. Because remember that a range, and again, it's hard to write on this, guys. And you're going to be frustrated too when you want Mr. Fortin to see your good work. It might be hard for me to read what you're doing, so I'll do my best. But anyways, remember, range are the y values or outputs of a function that are represented in a function or given by the function given out. What are all the y values that we have? So we can actually write this answer. And one better way, a nice clean way, I know you're talking about range, is if you do this, you do -1 is less than or equal to y is less than or equal to 3, okay? So here, y is bounded, right? Our y values are between -1 and +3 right here. That's the highest we get on the graph, right? We get there at 3. So that's the range of the graph. So summarizing these two here, we have our domain of this particular function relationship here is -2 to 4, or -2 is less than or equal to x is less than or equal to 4. And our range of this particular relationship here is -1 is less than or equal to y, which is less than or equal to 3. All right, let's keep busting on here, guys. I remember I said it was like one problem, but this takes a long time. It takes a long time. I hope you're watching this too, because I think there's a lot of chances for kind of misconceptions here. So hopefully I'm catching them for you guys here. All right, Ricky thinks the range of this is g of x equals -1, 0, 1, 2, and 3. Is he correct? Why or why not? And if you're following the last slide here, no, he's not correct. You might be thinking, Mr. Fortin, why? No, he's not correct. I'm gonna have to put some, I think I might have to put some places for you guys to write these answers in. He's not correct because, like for instance, is -0.5, could that be part of his range? Look here, -0.5, that's like here in the graph. Look, -0.5, we have a point right there. There is this point right here that would be like -0.5. So 2.5, we have a y value here. Like this point of the graph would be up like this point graph right here. This point of your graph like would be about, I don't know, 0.75 for x and 2.5 for y. So sure, 2.5 is part of the range, right? Part of the range. Okay, so Ricky is not including. He's not including the decimals here. No, he's not correct. He needs to include decimals or non-integer values. Include, this is crazy, decimals in his answer for range. Answer for range. And so that's why for range, I wrote it this way, okay? I wrote it like this. I wrote -1 is less than or equal to, this is driving me crazy, less than or equal to y, which is less than or equal to 3. Okay, so this is a better way to write it, because if y were 2.2, right, we have a point at 2.2 for y. It would be like right around here or so, okay? So the range includes the in-between values, right, the decimals, not just the whole numbers or the integers we see here. All right, let's keep jamming on here, guys. Hopefully you're still watching, staying with me. I think it's worth watching this one. What other functions have you worked with previously in this course or previous courses that have limited ranges? How are they limited? Well, maybe you thought about this one. Maybe like something like this, y equals x squared. And y equals x squared, right? The range of that one was that y is greater than or equal to 0, for instance, right? So this has got to be positive, right? Got to be positive because any number squared is a positive number. Any number times itself is going to be a positive number because 2 negatives times itself is a positive number, right? And 2 positives multiplied to itself is also a positive number. So quadratic functions have a limited range. An absolute value function also has a limited range. There are probably several other ones. Square roots, right, have limited ranges depending on what direction it's facing, of course. So plenty of things that we've worked with here that have limited outputs, that are limited to only certain values. It's not going to be just any random value, potentially that here. Okay, exit ticket here. You guys can handle that one. You can answer it like in your own words. What's the difference between this? What's the difference between domain and range? How am I feeling with this? Hit me up with any questions. I'm going to wrap it up with the video. You're all done. Hopefully you've watched it. Let me know anything else you might want to say beyond just the exit ticket right here. Take care, guys. Have a good night. Bye.